Video we're going to take a look at how to find vector components when given a vector, or how to go from the components of the vector and go back and get the magnitude and direction. We're going to be using some right triangle trigonometry to do this. So you got to remember your SOHCAHTOA, your sine, cosine, and tangent. All right, so here we have a vector v. Let's say this is a velocity vector, right? And we say that this velocity vector has a magnitude, that's the length, and it also has a direction. So it would have it would have some angle theta here that in this case it's making with the x-axis. All right, so let's first talk about the horizontal component of this vector. That would be the x component. And I envision a flashlight. So here is my really well-drawn flashlight, and we're shining some light down on this vector. Okay, so what I envision a vector is, at least the horizontal component of this vector, is the shadow that's cast on the ground, aka the x-axis, by this flashlight. And so here we can see that vector shadow on the x-axis. So this is exactly how many units to the right this shadow is. All right, so in this case, if we count, it's 1, 2, 3, 4, 5, 6, 7, 8, 9 units to the right. So let's say that our velocity vector is measured in meters per second. Then we would say that the x component of the velocity vector, which we could name Vx, it is itself a vector. It's got a length. In this case, it would be 7 units, or 7 meters per second, and it's got a direction. In this case, we could say it is pointing the positive x direction. All right, so we could actually give it a, what did I say it was, 9? Oh, I've got to count again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, positive 9 meters per second. All right, so the positive means we're going in the positive x direction, and the 9 is obviously the magnitude of that vector. Okay, so we're going to take our flashlight now, and we're going to shine it from over here on the vector. And so now the vertical component of this vector is going to be the shadow that's cast on the wall, or the y-axis in this case. So let's go ahead and do that. And the shadow cast on the wall then is this vector right here. And we can call it v sub y. Let's write in blue because I think that green's kind of hard to see. V sub y. It is a vector, and it has a magnitude 1, 2, 3, 4 units in the positive y direction. So I could say it's positive 4. And again, let's say it's a velocity vector, so we're talking meters per second. All right. So that's the horizontal component, that's the vertical component. Think of them as shadows cast on the floor and the wall for this velocity vector. Okay? So the lovely thing about my horizontal and vertical vector components is that they make a nice, lovely right triangle with my original vector. So dragging that vertical component over to complete our nice, lovely little right triangle, now we get to use right triangle trig to do some fun stuff. And I just totally messed up my, there we go. To do some fun stuff with this vector. So we don't know the magnitude of vector v, right? All we know is the magnitude of its components, but it's our right triangle, right? So we can do, what is that thing called? Pythagorean theorem. We've got 9 squared plus 4 squared. We take the square root of that, and we end up with a magnitude of about 9.8. And that's just a coincidence that it's the same magnitude as the acceleration due to gravity. But it's about 9.8 meters per second. And let's say we also want to find the angle theta. Right? Well, we have the opposite side of the triangle from theta is 4. The adjacent side to the triangle, to the angle theta, is 9. So opposite over adjacent, we're looking at the tangent function. So we can go, the tangent of this angle theta is going to equal opposite over adjacent, 4 divided by 9. And the reciprocal operation, or the opposite operation of a tangent, is the inverse tangent, or the arctangent. So we take the inverse tangent of both sides, and that gets rid of the tangent here. So we're solving for theta. It's the inverse tangent of 4/9. So find that inverse tangent on your calculator, and go ahead and throw it in there. And according to my calculator, we end up with an angle that is pretty darn close to 24. So theta is equal to 24 degrees. If you got a weird number other than 24 degrees, then your calculator is in radian mode, and your angle measure is given to you in radians. So you need to switch that mode into degrees to get that 24 degree angle so that it makes sense for us here. All right, so now I can also talk about my vector v being 9.8 meters per second long at an angle of 24 degrees with the positive x-axis. Okay, so we can talk about vector v either that way, giving its magnitude and its direction. Notice I gave that direction in reference to something, the positive x-axis. Or we could talk about that vector v in terms of its components. It's got a vertical component of positive 4 meters per second. It's got a horizontal component of positive 9 meters per second. They all mean the same thing, and we can talk about them the same way. So now let's look at an example where I give you the magnitude and the direction of the vector, and you are going to find the components for me. So here's our vector. Let's say this is like the launch vector of a projectile. So we know it's launched from the ground, let's say, at 30 meters per second with an angle of 40 degrees with the ground. So the first thing I'm going to do is sketch in my horizontal component of the vector and my vertical component of the vector. All right, so those again make a right triangle, so I can pick that blue vector up and I can move it over, and I'm going to do that here to make my nice little lovely right triangle. So now I know the hypotenuse of this triangle is 30 meters per second, and I know the angle in there is 40, so we want to find Vy over here. Okay, well, Vy is the side opposite of the triangle from that 40 degree angle. So we know the hypotenuse, we know the side opposite. Which trig function are we dealing with? Opposite over hypotenuse is the sine. So we know then that the sine of the angle is equal to opposite, which is Vx, that's what we're trying to solve for, divided by the hypotenuse. So multiplying by 30, we get 30 times the sine of 40 is equal to Vx. Throwing that into the handy-dandy calculator, I get back from my calculator 19.3 approximately meters per second, and that is my why was I calling this Vx? That is a mistake. Let's go back and change that. We're talking about Vy. Okay, mistake fixed. So that's the vertical component of the velocity, and it is going up, so I'm going to throw on a positive right there to tell me it's going in the positive y direction. All right, we're going to do something similar to find the x components, the horizontal component of this vector. Notice it's the side adjacent to 40, and we also know the hypotenuse. So adjacent and hypotenuse, we're looking at the cosine. So we start with cosine of 40 degrees is equal to the side adjacent over the hypotenuse. Again, multiplying by 30, we get 30 cos 40 is equal to Vx. And again, throwing that in my handy-dandy calculator, I end up with, what do we got, 23.0 meters per second. And that is my x component. But remember, that component is also a vector. What direction is it pointing? It's pointing in the negative x direction. So let's slap on a negative there so we know what direction we're talking about. All right, so now I have my components of my vector, and away we go. I know that in the horizontal direction, this thing is launched with 23 meters per second velocity to the left, and that's going to dominate the horizontal motion of this projectile. And I know that its vertical component is 19.3 meters per second launched upward. Okay, so the upward motion of this projectile is going to be determined by that and gravity. Okay, so that's why it's important that we're able to find the components of this velocity vector, because I need to use it when I'm talking about this specific case of two-dimensional motion, projectile motion. We'll be finding components of other vectors in the future. So this is a really important skill for us to have, and something that needs to be automatic for you, right? You're looking to the opposite side, you've got the hypotenuse, automatically you should be thinking sine. You've got the adjacent side, you've got the hypotenuse, you automatically should be thinking cosine. All right, and just check that calculator mode. Okay, if we're actually throwing numbers in here, we're going to be using degree mode so that our angles make some sense to us. That's it for now.